right, so we're going to take on 6.1 part 2 here and continue talking about applications dealing with our quadratic functions. So, talk about a rock is dropped off of a cliff. Its path can be modeled by the function of h of t equals negative 16t squared plus 64. So we're going to answer the question geographically and algebraically. So with this, we're going to look at doing algebraically first. So we can simply say that we have, when did the rock land? Okay, so we have h of t equals negative 16t squared plus 64. So we know h of t, in other words, our height, we know that's 0. So for this one, your h of t equals 0. So we're going to say 0 equals negative 16t squared plus 64. Okay, and then we're going to solve for t. So let's go ahead and subtract 64 from both sides. Go way over there, and we're left with negative 64 equals negative 16t squared. Then we're going to divide by negative 16 to get rid of this guy. Oh goodness, I need to draw a line. So the negative 16 is going way over here, and when negative 64 divided by negative 16 gives us a positive 4, and that equals t squared. Then we're going to take the square root of both sides to get rid of that squared, and we should get t is going to equal plus and minus 2. Okay, so that means t is going to equal negative 2 and t is going to equal 2. Well, we can't go back in time. When you drop a rock off a cliff, can't go back in time. So in other words, it took t equals 2. So in other words, it took us 2 seconds. 2 seconds to hit the ground. So the rock landed in 2 seconds, okay? In which case we can look at this geographically too. If we look at this geographically at the graph they gave us, again, 0 and 64, which again, if you put a 0 in for t up here, you see it started at 64. So 64 feet is where we're starting out at. And then you drop the rock. Well, and the fact you just dropped it straight down, it took 2 seconds to hit the ground. That's why you've got this parabola started here, okay? So it took 2 seconds to get down to 0, or height of 0. Started at a height of 64 and went down to 0, and it took 2 seconds. So when did the rock land? Well, we took 2 seconds. Okay? So let's do some more with these types of problems. So we got some functions here, the objects in projectile motion. Let's find out how long it took for each object to land, okay? So in other words, we're going to put a 0 for all of these guys. We're going to make this all the heights equal 0 and solve for these. So let's do that. So working through these, we're simply saying that you got your 0, there's my pen, I lost my pen there, 0 equals negative 16t squared plus 160t. Okay, and so now I can simply see that there's 16 and a negative 16 at that, as well as a t can factor out of this. We can simply say negative 16t, of course that'd be times the t to get negative 16t squared, minus 10, because negative 16 times a negative 10 gives me positive 160, and there's already a t right there, so that'll give us a t, so 160t. All right, now we can simply do this by taking each one of these equal to 0. So negative 16t equals 0, and t minus 10 equals 0. And to solve for t over here, we get t equals 0 or t equals 10. Well, time is 0, we know the height is at the top, right? So it took 10 seconds to get all the way to the bottom. So 10 seconds is our answer. All right, so now we'll do this one. Again, we want it to land. So our height is 0, and we're going to equal negative 16t squared plus 20t. And let's look at this. What can we factor out of this one? Well, I know a t can factor out for sure. I'm just going to take a negative 4. Negative 4 can go into both those numbers. So negative 4t times, well, I'm going to get a positive 4t to get overall a negative 16t squared if I factor it back in. And then we're going to say minus, oops, sorry about that, minus 5. Because negative 5 times a negative 4 gives you positive 20, and then that has a t on it as well, so it gives me overall positive 22. I multiply back in the parentheses. So again, let's do this. Set it equal to 0. And 4t minus 5 equals 0. So over here on the left, we got t will equal 0 overall for that one. And if we add 5 to both sides, and we get 4t equals 5, and then we divide by 4. So t is equal to 5 over 4. Or you can simply say 1.25. So again, 0 is out of the question because that means the top of where it started from. So therefore, we have 1.25 seconds is our answer. Or you could have simply wrote 5 over 4 seconds. Okay, so let's do it on this next one. So again, we're going to take 0 equals negative 16t squared plus 16t plus 192. All right, and now let's see what we can do here. We can definitely take out a negative 16 again. Okay, and that will leave us with a t squared minus t minus 12. So now we can do our big X on this case, right? Let's factor that on the side there. So we got A is a 1, or C is negative 12. So we got negative 12 up top. And our B value is negative 1. So in this case, we need to find two numbers that multiply by each other to give us a negative 12 and add up to negative 1. Well, 3 times 4 will give me 12. I want to be a negative 1, so I'm making negative 4. So if I take 3 times negative 4, that'll give me negative 12. If you take 3 minus 4, that'll give me a negative 1. Or you say the way I talked about, adding them together, right? So 3 plus a negative 4 will give me a negative 1. So then we just do bottoms up, and that'll give us our 2 that we need to worry about. So in this case, we got negative 16 times t plus 3. Sorry, my t's looking really bad today. And you're probably saying, well, Miss Jelly, it always looks really bad. I'm sorry about that. So that's my t plus 3. And then you got t minus 4. Okay, so now we just need to set them equal to 0 again, like we've been doing. So in this case, we got t plus 3 equals 0, and t minus 4 equals 0. So we would get t equals negative 3 or t equals 4, okay? In which case, we know that we can't go back in time. We can't go a negative 3 seconds, so that's out the window. So we know we got 4 seconds to hit the bottom is what we're looking for. All right. Do 3 more of these real quick. So again, if you do this, let's find out how long each object land. So again, we're still doing the same thing. 0 equals negative 16t squared plus 32t plus 128. And I'm pretty sure we can factor out a negative 16. So we'll put t squared minus 2t, and then minus 8. Okay, so now we can do our big X. 1 times negative 8 is negative 8. Our B value is negative 2. So we need two numbers that multiply together to give you negative 8, but add up to negative 2. So I'm going to say we take a 4 times 2 will give me an 8. And you add up to negative 2, so I'm going to say negative 4 plus 2 will give me a negative 2. So bottoms up, in which case we got 0 equals negative 16 times t minus 4 times t plus 2. And if we take that, t minus 4 equals 0, and t plus 2 equals 0, we get t equals 4 or t equals negative 2. And again, negative 2 can't go back in time, so we got 4 seconds. Okay, so the next one, 0 equals negative 16t squared plus 144. And we can go ahead and do this. Let's solve for the t itself, and then we'll take the square root of both sides. So let's subtract 144 from both sides. All right, then we're left with negative 144 equals negative 16t squared. Divide by negative 16. And the 16 goes away over here, and we're left with, over here, we got 9 equals t squared. The square root of both sides, left with t equals plus or minus the value of 3. Well, we know we can't have a negative 3 value, so our t is going to simply be 3 seconds. That's what we're looking for. All right, the last one we're going to work on like this. We got 0 equals negative 16t squared plus 81. Let's subtract 81 from both sides. And therefore that goes away, and we're left with negative 81 equals negative 16t squared. Divide by negative 16 on both sides. Goes away, and that is going to leave us with a little bit of a decimal here. We're just going to go ahead and write that out here. In this case, we can simply say we've got a positive, I got a positive 5.0625, and that equals t squared. And then we take the square root of that. So when you take the square root of that value, you're left with t is equal to 2 plus or minus 2.25, in which case we can't have a negative value, so 2.25 seconds is fine. Again, I did use a calculator on that, but I already had these worked out number-wise crunched, so it makes it a little bit faster, and you don't have to watch me punch numbers. All right, so now, dealing with profit functions, often form parabolas as well. Think about it. If you price something very low, many will buy it, but you will not profit much because of low price. If you price something very high, very few will buy it, resulting in a small profit as well. But we can find a price, not too low, not too high, that will maximize the profits overall. Okay? So when we're dealing with this, we're going to look at Sarah makes custom iPhone cases. Her monthly profit can be modeled by P of X equals negative 20x squared plus 1920x minus 9100, where X is the price she charges and P of X is her monthly profit. Okay, so with this, we're going to look at these and say, well, what should she charge to maximize her profit? Well, we got to find that peak point, that vertex point, okay? And if you remember correctly, that we talked about in the previous lesson, that equation is negative b over 2a to find your max value in the parabola. So in other words, our b value was a 1920, so we have a negative 1920. I'll write these out of here so don't get anybody confused where I'm going. A is negative 20. Your B is 1920. And your C is negative 9100. So a negative B value, so negative 1920, all divided by 2 times negative 20. Okay, so we should get negative 1920 over negative 40, and that gives us 48. So the max her profit is $48. Okay, and what will her maximum profit be? Well, if we charge $48 for every item sold, which is X is the price she charges, right? We set that up here. So we plug in 48 into her equation. So we're simply taking P of 48. Instead of an X, we're going to put the number 48. That equals negative 20 times 48 squared plus 1920 times 48 minus 9100. And when you crunch those numbers out, you should get 36,980. So her maximum profit will be $36,980. And if she charges $0, what will her profit be? Well, again, you're doing the same thing, but putting in a 0 for all these guys up here. So instead of writing this all out, you put a 0 here. That's going to make that go away. You put a 0 on this X, it makes that go away. Well, what's left? If that goes away and that goes away, you're left with negative 9,100. With that, the overall profit would be negative $9,100. So what is her profit? What is her profit if she charges $60? Okay, so if she charges $60, again, we're just plugging that 60 in like we did for the 48. So again, instead of a 48, we plug in a 60. So we'd have negative 20 times 60 squared plus 1920 times 60 squared minus, oh, I'm sorry, not squared, times 60 minus 9,100. And when you crunch those numbers, you should come out to get a value of 34,100. So price of $34,100. Okay. So now let's look at the graph and see how this plays out with this a little bit more, right? So we're looking at this graph in the context of this problem with this saying P of 110. So the price that she's selling for her products is 110. So if she was to charge 110, which means she charges $110 for cases, she will take a $39,900 loss. Do you think that is true? And explain. Well, $39,000 loss? Well, no, the smallest possible profit would occur if she sold 0, which is negative 9,100, right? The smallest profit she could make is if she sold nothing. She sold none of them. If she sold none of them, she would lose 9,100. So if she charged, or she sold, oh, sorry, if she charged 110, then it wouldn't make sense, right? Because 110 would be way over here, somewhere way over here. Okay, and she would that would drop that number way down here, the dot's way down here on the line of negative 39,900, okay? So we were gonna say no, okay? smallest profit is 9,100. So smallest profit is 9,100 if she sells 0 product. So if she sells 0 product, then she's good. Or if she sold 91, if she priced them for 91, then that would work out that way as well. Okay? So in this case, that is how that plays out for this one. So let's look at this just by looking at the graphically. We could answer all these questions if they had a graph for it, right? So what should you charge to maximize their profit? Well, to maximize their profit, as we saw right here at the top, we did that first equation. We said that we should do 48, right? Because 48 bucks gives her $36,980. That's the highest profit she's going to make. So she should sell her product for 48 bucks. What will her maximum profit be? Well, we just said it. It's going to be $36,980 because that's what she's going to make. And then she charges $0. What will her profit be? Well, she just gave them away. She'd lose 9,100 bucks. So she would lose a negative 9,100 bucks. All right. So cost functions often form parabolas that open up. The larger a business becomes, the more expenses it has, materials, staff, facilities, etc. So Jack started a business making and selling fashionable hats. Below is a graph of his costs. C of x equals 0.005 x squared plus 3x plus 1,500, where C of x is the cost of producing x number of hats. Use this function and its graph to answer the questions below. So interpret the meaning of the ordered pair 1,000 and 9,500. Well, if by looking at that, x, your x value is going to be the number of hats. So if he produces 1,000 hats, it should cost $9,500 is what that's saying. In which case, that's what we're going to write down. It will cost $9,500 to produce 1,000 hats. That's what that point is telling you. Okay. So knowing that x represents the number of hats he produces, select the appropriate domain. So we're looking at domain, right? Domain is dealing with your x-axis. So with your domain, right, can you produce negative amount of hats? No. Can you produce an infinite amount of hats? Yeah, that problem is going to go on forever and ever and ever. So the only one that has an infinite result overall and starts at 0 is going to be letter C, because we're starting at 0. We're starting right here, and it's going to go on forever and ever and ever, all the way up to infinity and beyond. Okay? So again, C is going to be your answer for this guy. So now, the same type problem. How much did it cost him to start this business? So let's think about how much did it cost for him to start this business? In other words, what are we going to look at? With this, you're going to look at saying that the start of the business, in other words, 0 hats, right? Sold 0 hats. So for 0 hats, how much did he have to pay? Well, if you plug in a 0 to all of these x values, zero squared is 3 times 0 plus 1,500. Well, you're simply going to say that you have 0 plus 0 plus 1,500. In other words, it costs 1,500 bucks to start up the plan, start up the business. So $1,500 to start up the business. All right. And does the vertex have any significance? And explain. So the vertex, as we're talking about this point right here, the vertex. In other words, let's say that's negative, what, 300? Negative 300 hats? In which case it would have made 1,000, cost 1,000. So to make negative 300 hats costs 1,000. So does it make any sense? No, the vertex tells us to minimize cost. So Jack produces negative 300 hats for $1,000. No, you don't want to start there. You'd want to start with 0 hats for $1,500. So just think about the question overall in a business, in this type of problem, definitely in a business aspect of how you would look at that. That's telling you if you make negative 300 hats, it's going to cost you $1,000. That makes no sense at all. Okay, so just think about it outside the box a little bit. All right, so hopefully that helped explain things a little bit more in the application with quadratic functions. I'll see you next time.